Well, hi everybody, it's Tim here again. This is a video especially for Dom. An explanation of voltage and how things work through your house. First off, I figured I'd just cover something that you hear all the time. Difference between AC and DC. DC's things like batteries. AC is the stuff that comes out of your wall at the house. The two signals you're looking at, the purple one is a DC signal, and the yellow one's an AC signal. Now if you look, the DC signal right here, that little purple line there, that's the starting point, or 0 volts, or and then the yellow is the same thing. The yellow, that's the starting point, or 0 volts. If you notice, the DC goes above it to a given value, depending on, that happens just to be a 5-volt system right now, and it stays there. Now if you look at the AC, I had to turn that scale's way down, but that's what's coming out of your house. That goes above and below 0. And the amount of times it does it in 1 second is the frequency, or 60 hertz. It does that 60 times in 1 second, pretty quick. But as you can see, there is a point where the voltage does drop back down to 0. Now as far as anything that runs off this, it doesn't care if it's below or above 0. It goes with the absolute value, kind of like how in math. All it cares is how far away it is from 0. It doesn't matter if it's plus or minus. So the problem is when it's at 0, it's 0 volts, and then it goes back up to 110 and back down to 0. And not that that's a problem, but that's just how it works. And just about everything in your house, that other than light bulbs and simple things like that, they do run on DC. So that's why there's an integral part of all those appliances is a power supply, and that turns it to DC. Why the power company didn't send DC to your house? It's easier and more efficient to send AC out along the lines than it is DC. And you can look at Nikola Tesla and Albert Einstein. Not Albert Einstein. His name just escaped me. They were the two pioneers that kind of wanted to go DC, and the other one wanted to go AC. And they found that AC was a whole lot better at moving power through the area. Anyhow, so that's why we have AC. So that's what we're going to talk about a little bit today. In your house, in AC, the majority of houses here in the United States, North America, have 220 volts, around that. Some people might say 230, some people might say 240, but generally it's, for today, we'll just say 220. And the 220 gets divided in half, and you have 110 and 110, and that makes up the 220. So I'll show you how that works, and we'll sum it all up. And I meant to say Thomas Edison was the other pioneer from early electrical, not Albert Einstein. One thing I did want to add about DC power, and it's batteries. And a lot of people get under the misconception that a bigger battery just means more voltage, and it doesn't work out that way. Mainly, if you think about it, a little watch battery can be 3 volts, where a big flashlight battery is only 1.5 volts. So the size has more to do with its ability to last and provide current. So for instance, you know, a 9-volt battery that's pretty small compared to a car battery, which is pretty big. Try and crank a car over once with a 9-volt battery. You really won't get too far. So that's the main thing. So when you see batteries, don't get confused with the battery size having much to do with the volt. Right? So just a quick look at this. We're not going to spend too much time on that. People will get bored to death. So here's the voltage coming in from the excuse me, out on the phone pole. Excuse me. And then there's a transformer that'll be out on the phone pole as well. Then when it comes in, it steps the voltage down to 220 volts. But if you look, they put a center tap right here. Aha! And then you can have 110 volts from the center to each leg, or 220 total. Things like dryers, any big power-hungry appliances, so to speak, air conditioners, things that may be things that may have motors, dryers, air conditioners, that kind of thing, compressors. They'll run on 220. What do you call this? Electric ranges, they run on 220. But the rest of your lights and everything, they can be 110. Now, I mean, you could put your light bulb across 220. It would probably wouldn't last quite too long, but they could make an easy, and they did. Used to make, excuse me, 220 volt light bulbs. So, just real quick, if you notice, there's no actual electrical connection between these two. They actually work on the principle of the coil building up a magnetic field, discharging the field. And not to say that a short circuit down here won't be felt here, but it won't burn up all the wiring here. So it's not felt as much. Anyhow, out on your utility pole, you have a transformer. It steps it down when it brings it into your house. The primary voltage is much higher, and it's really not part of this, but the reason is it's easier and more efficient to send AC voltage at higher voltage and lower current. So when it's out on the pole and before it gets to your house, it's at some points it can be very high. And what happens is when it gets transferred, power factor in a transformer is equal, which means if you have the ability to do, say, 1,000 watts here, it can do 1,000 watts there. So power is calculated by current times voltage. If you have, we're just going to pick two random numbers, 1,000 volts at 10 amps on this side, and you step it down, you could step it down to 500 volts, which will be cut in half, and then double the current at 20. So you would end up with the same power factor on each side. 1,000 times 10 is 10,000, and 500 times 20 is 10,000. So you see where I'm going with that. So anyhow, what happens is when they step the voltage down, they step the ability to get the current up. Most of your houses nowadays run with at least a 200 amp service. Back in the old days, they had 100 amp. You probably still see some of those around, and even 60 amp. Some of the 60 amp services didn't even have the ability to do 220. They were simply 110. There wasn't a center tap on that transformer. You won't see many of those out there anymore, but you could. Okay, well, with that in mind, I just want to tell you that I am not professing to be an electrician, nor do I recommend, if you don't know anything about electricity, that you go out and start to mess with your stuff. Contact a qualified person that knows how to do the stuff. This is just to give you a little insight on how things work. Yeah, in your house, one of the things I did want to add, in your house you'll have all different types of plugs. Like I said, you can have, and I know I show the 110 volt plug, but you can still have some 110s without the ground. They just have the two slots. Some that aren't polarized at all, those are the very old ones, the ones you'd want to get rid of and replace for people as an electrician. And then there's the 220 volt plugs. Those are, a lot of times they're specific to what they do. So if you went to Home Depot, you would say, hey, I'm looking for a range plug or a dryer plug. Or they'll say a 50 amp or a 30 amp, but each one of those plugs is specific. There's one other type of plug you may see out there, depending on what you're doing, and they're called hospital grade plugs. And they usually have a little green dot on them. Off we go to a sightseeing field trip. So that thingy right there is the transformer. And if you look, I guess for lack of better wording, the primary wires are above it. And then the wires coming into the house, right there, come off the transformer. Now on some of them there's actually wires above those three, and they're higher tension wires, so to speak. Okay, so then the wiring comes over to that thing right there is called a weatherhead. Then the wire that comes down here is an entrance cable, and it comes down to your service box where the meter is. Now on the other side of your entrance cable is where the service box is. Breaker box, fuse box. You can see where the entrance cable comes in right there. Runs down into the box. Then inside the box you have a main breaker. That's at the top. And then all the other breakers control things. Now some of them you might notice maybe are tied together, like these two right here. See if I can zoom into them for you. Alright, these two right here, these two right here. There's quite a few of them like that. And what they indicate is those are 220 volts. Now, when you looked at the cable coming into the house, you saw that there was, if you picked it up, 3 wires. And basically there's 2 huts and a common. And I'll explain that in a minute. But that's how we derive at either the 110 or the 220. Now this is for North America. If you're watching and you're somewhere else, you're pretty much on your own. So then once we've made it past the breaker box, the power gets doled out through the wires to one of the many different types of outlets. The one you're looking here is a standard 15 amp, 110 volt outlet. Main things to notice about this is on the right side is the smaller terminal, and then the little round one here that makes the mouth. So the little round one at the bottom is your ground. The smaller of the two, and I don't want to move the camera again to point, but as I'm looking at it, it's on the right. That is actually the hot, and the larger of the two, which is on the left, is the common. So all plugs will be like that, and that's called polarized. And you'll notice when you look at your actual plug to plug into the wall, one of those blades will be bigger than the other. So if you want to remember it, remember that the smaller one is the hot one, and that makes it less likely that some little kid's going to stick something into it. Hopefully if they're going to stick something in, they'll stick it on the big one, which is the common one, and that has the same potential as ground, which means if everything's wired correctly, nobody will get hurt.